introduced yesterday. There's a couple new ones here. My name is Terry. I've been with Precision Pumping Systems since 1999. We started in a small shop in Nampa, and it was, some of you guys met Tom Young, and then Rob Aldinger, the salesman, and then there was Mike, Pat and Randy's brother, and myself. And we pretty much did everything. And as we grew, put on a few more people. Then Randy got a little more involved in the company. Tom Young decided to go into sales, so then I became the manager. And we continued to grow, put on more people. At that point, Pat, the other brother, he decided to become more involved, and so we've grown quite a bit since then. From just 4 or 5 of us up to 24 of us now. So I pretty much do about everything around here. Do a lot of technical support. I order most of the big items, pumps, motors, filters, that kind of stuff. So if you need parts or anything like that, you can start with me. Also, technical support calls. Dave and I do most of those, but a lot of times Dave's out, so I do quite a bit of that too. So what we're going to do today is, it's a basic troubleshooting. We're going to look at our control panel. It's the same as if we sell a control panel or if we sell a system with a control panel on it. Just the basic components. We're not going to get into real technical parts of it today. We'll go through some of the items on a pump station, a little bit of troubleshooting on the pump station. It's all on a slideshow. So we'll just go through the slides, and please, if anybody has any questions at all, if you've got any experiences out in the field, similar to this or something, share them with us. I'd like to get all the questions answered. So you just holler, raise your hand, whatever. So again, we'll just cover safety, some of the tools for the job, the components in the panels, troubleshooting panels, and troubleshooting water system components, a complete system. Always like to stress safety. Always be aware that the power is off. Watch for all shock hazards. Don't trust that it's off. Use a multimeter. Check your voltage. Power from other sources. Occasionally we do see where you've got other controls coming in, especially if you get out into agriculture. I've seen 480 volt coming in from another standalone pump panel into one of our companion panels. And we turn our panel off, check the voltage in there. You've still got a few terminals in there that's 480 volt because of control. So just be aware of that. Look and make sure that there's no other conduits coming in, wires. Check your power. You might turn it off, and just because of a malfunctioning switch or other reasons, just double check and make sure that you measure across here. I always like to recommend too, if you measure power from phase to phase, like on this is a 480 volt system, you get 480 volts. Go through all 3 phases, but also what I like to recommend is go from each phase to ground. Because you are ground, you're standing on ground, and if there's something wrong inside this switch or something else tied into there and one of these legs are hot but the other 2 are not, you may not measure anything across these 2 coming in with that off, but if there is a malfunction or something, you may measure from here to ground on one of those legs, and again, you are ground. So just be careful, use common sense. I want to mention drive DC bus voltage. Many of you probably already know, but a drive stores its voltage on a DC bus capacitor bank in the drive. And when you turn power off to that drive, those capacitors stay charged. And depending on the drive type, the drive size, it could remain for several minutes. So just be aware of that. Here's one. This is an ABB drive. This is your DC bus right here. So if you have to pull the power wires or the motor leads out, you are kind of close. This one, is not so easy to touch. But there's another drive. Here's a Mitsubishi. You can see it's a little more open. These red, black, and blue here. These are your DC bus voltage, the red and black. If you do have to remove motor leads, here you could touch that. And on a 480 volt drive like this, you put your meter in DC volts, measure across here, you could measure as high as 700 volts. So on some of the larger Mitsubishi drives, it can take up to 4 or 5 minutes for that to go down. So if you do have to work on a larger Mitsubishi drive like this, put your meter in DC volts, measure this, wait for it to come down to a safe level, 50 volts or less. So always be aware that a VFD drive can store that voltage on its DC bank for up to several minutes.
Terry, a measure across the red and the black?
Yeah, across the red and the black. Some might have a brake chopper or other options that would use this terminal. I think it is also still hot, but you would measure across the red and the black on DC volts. Some of the bigger Mitsubishi drives, it's not in here, but right above here, there's a little red LED. That will go out when it's safe. So if you do see a red LED on a drive, wait for that to go out or use your meter, one or the other. Turning power back on, I always like to recommend that you close the door before you turn the power back on. If you've had to open the door to reset a breaker or for any reason, close the door before you turn it back on. I have seen a lightning arrestor explode once in my years. You might have, I've heard of overloads, breakers being damaged when it's turned back on. They tripped for a reason, you reset it, power it back up. It tries to trip again, but it might be damaged or contactor welded or something. So just always, close the door before you turn it back on. Just real quickly on some of the tools for the job. A terminal screwdriver, you'll notice when you look in our panels, and I've got a couple of pictures here, the terminal block on a PLC, they're really small. We have a field terminal strip, we call it, at the bottom of all our panels. That's where all the field items come into. They've got small terminals too. I get a lot of calls every year that they have to go find a screwdriver and call me back because we can't get to those. So if you are going to do startups or work on these or basic troubleshooting, it's about 1/8 inch wide at the bottom. Make sure you have one of those. Clamp on amp meter, those are pretty handy, not absolutely necessary, but a lot of times when you're troubleshooting a drive or a motor or something, a clamp on amp meter can be handy. Sometimes if a drive won't run full speed, we might check the incoming current on all 3 legs, and if one of them's gone or half of what it should be, that would indicate some bad input diodes on a drive. Same thing on output of a drive. If it's faulting on overcurrent or motor problems, you might put a clamp on amp meter on all 3 motor leads just to see if they're all within tolerance. So occasionally you would need a clamp on amp meter. Motor megger, that's another one that can be handy. Not very many people have them. It's not, if you don't have one, I wouldn't worry about it, but they can be handy to have a motor megger. These newer digital ones like this, they've really come down in price. I think you can pick these up for 70, 80 bucks. The older crank style used to be several hundred. But occasionally a motor megger might come in handy. I have done a little bit of troubleshooting over the phone where it was either it's a bad motor or it's a bad drive, and we just can't determine exactly what it is, and so they would need to go get an electrician that has a motor megger and come back and double check before they pull a pump out of a well that's 100 foot deep or something.
These won't work on a submersible.
They don't work very good on a submersible, no they don't.
They won't. You gotta have the hand crank to it.
Especially with long motor leads. And then of course the digital multimeter. They used to recommend an analog multimeter, the drive manufacturers did, but we found that most of the newer digital multimeters now will measure the output of a drive okay well enough to do your basic troubleshooting. So an analog multimeter, I don't think there's many around anymore. We don't use them much anymore either, but a good digital multimeter is almost a must if you're troubleshooting on a pump station or calling for technical support, something. We're always having to check, measure something.
True RMS.
Right. Okay, we'll just look at the front of a couple of our control panels just to show that the basic components are all the same.
You said RMF.
This one is a pretty simple one. It's just got we took the keypad right off the front of an ABB drive and then ran an Ethernet cable up to it. That way we don't need an HMI. At least we have something that we can see. This can display, you know, when it's running, what the hertz are, what the pressure is. All of our panels are going to have basically at least what we call an HOA, a handoff auto. So in auto, it's going to run under pressure mode. It's going to try to maintain a constant pressure, whatever pressure it is that you tell it to maintain. So that's in the auto mode. This manual speed control down here doesn't do anything when it's in auto. The drive doesn't even look at it, so it doesn't matter where that's cranked when you're in auto. It's just going to run in auto in PID, what we call PID mode, which is maintaining a constant pressure. Another thing to keep in mind is that when you switch to hand mode on almost all of our panels, especially our pump stations, in the hand mode it's basically mostly for testing, and so it overrides all the safety functions. If that system has a high pressure switch on it or a low flow switch on it, it's not going to fault out when you're in the hand mode. Once you go to hand mode, the drive then looks at this manual speed control. So you just simply dial it up or down, it follows that speed. But be aware it's not going to shut down on high pressure. If you crank that all the way up, depending on the pump or the system, I mean, you could get 150 PSI within a few seconds. Another thing to keep in mind is that because most motor manufacturers recommend a minimum speed, we will program in the drive a minimum frequency of 30 hertz. So when you turn this to hand, the drive's going to automatically go right to 30 hertz, regardless of where this is at. If it's anywhere below 30, it's going to go right to 30. And then once you start to turn it up, it won't speed up until you get above 30. Once you get above 30, then you'll be able to adjust it from 30 to 60. But just keep in mind that as soon as you go to hand, it's going to go to 30 hertz regardless. Most pumps won't do anything at 30 hertz. They won't create hardly any pressure. There are a few that will, but for the most part, most of them aren't going to do anything at 30 hertz anyway. So you'll turn it into hand, it'll go to 30 hertz, and you might see a couple pounds. Here's another one. It's a pretty basic one, but instead of the keypad, we put a HMI on the front. We've got several different kinds of HMIs. I think Devon's going to go through a little bit on what our HMIs do, and I always call them a touch screen. So if I'm talking to you on the phone or helping you, I'll call it a touch screen. So again, you'll notice it's got the handoff auto, manual speed pump. I did want to mention one other thing back on this one. Notice up here it's got a local remote. This one's not being used, but we will put that kind of as a default, and if we do use it, we'll put a switch there. What that switch is for, if you're in local mode, that's local to this panel. That means that it's going to run no matter what. It doesn't have to wait for a remote signal of any kind. If it's in remote, that means that even though it's in auto, and if it's in remote, it's going to wait for some kind of outside signal, like a sprinkler clock, out of the master valve with a sprinkler clock, pivot, whatever you might have. It's going to wait for a signal from that outside source before it starts. Now, again, hand will override that. It'll start in hand regardless. So if you come up to a panel like this and it does have the local remote switch on it and it's not starting, you can just quickly switch it to the local and see if it starts or not. If it starts, you know it's something to do with that remote signal coming from the clock or something. If it don't, then you're going to be looking at the control panel or drive or something. Another one with a little different touch screen on it. This one has normal power fail buttons. The red light will come on anytime there's a fault. If power's okay, you'll see the green and the red. But the red light will come on if there's a fault. It should also display a fault right here where it says system normal. It'll display a fault, you know, low water, high pressure, low flow. And then, depending on how many motors it is, this one's got several handoff autos. We've got a jockey pump here, pump 1, 2, and 3. I think if you notice the one downstairs, it's got another one down here. It's for the amnion filter, test off auto. So the front of our panels are pretty basically the same. Once you know one, it's just if it has more operators or not. Another thing I want to point out on this one too is a lot of times if we're troubleshooting, especially if we get a VFD drive fault, the PLC or the touch screen will display a fault, but we don't know the drive's got so many faults that we don't know what every single fault that it has, and so it might just display just VFD fault. In that case, you're going to have to open the door and read the fault on the drive. In many cases, if you turn the power off to open the door, you've reset the fault in the drive. And if that condition doesn't occur, you have to go into the fault log and that. So, and for other reasons, sometimes it's handy to be able to open the door with the power on. So what I wanted to show is, you'll notice that almost all of our main disconnect handles are this ABB style. This has a small button that sits right here next to that O. It's on the off. It's depressed, and it's hard to see. You have to get right up there and look at it. It's flush, not depressed, I'm sorry, it's flush. It's about 1/8 inch round diameter, and it's flush with the sides, so you can't really see it, but if you have a small screwdriver or something, you can depress that button. It'll release the handle, and you can open it without turning the power off. Yeah, or pen will work. So just push that little button, and they don't always just come right open. Sometimes you have to wiggle a little bit, but you can open the door without turning the power off that way. Okay, we'll look at some of the components inside the control panel. They're, for the most part, you know, it's the same thing. We got a control transformer in each one, a main disconnect. This has a Mitsubishi drive, ABB drive. Lightning arrestor. This one has a lightning arrestor in the back. But they all have breakers, power supplies. So we'll just run down through this one here on the left a little bit and just take a quick look at some of the components that are in there. Typically, after our power comes through our main disconnect, we'll have some kind of a distribution block, and that's where we distribute the 480 volts to all the different components. So like on this one, we have main power coming into a main contactor. We're coming over to the top of different items here, up to the control transformer. So we distribute our 480 volt from there on down. Here's the next view. You can see power comes in through this overload and through a contactor and over to the drive. It comes down to the top of the on-rod contactor, these other breaker overloads here. Then you also notice here that we have a splice block. We put this in here because it's easier to connect motor leads up to this. A lot of times the motor leads are larger, especially if they have to be run a long distance. They might be larger. You have to take the cover off the drive and put them in. So we'll supply a splice block like this in a lot of cases. But just note that there's always a label at the bottom down there that will tell you it's motor output. So just a little more convenient to hook the motor leads up to here. We got a motor saver, and then we got a field terminal strip. Again, there's a label for this field terminal strip down in the bottom of the panel that corresponds to every one of these terminals. It'll tell you what it is. So if we ever refer to a field terminal strip, that's what we're talking about. It's real handy for testing, troubleshooting stuff, because all the pressure transducer, pressure switches and that all come in and tie into right here. So we'll look at the control transformer first. Notice that there's 3 fuses on here. They're labeled F1, 2, and 3. These kind of serve a dual purpose. You'll notice that our primary 480 volt input on the primary of the transformer comes off of fuse 1 and 3. And we also run fuse F1, 2, and 3 also go down to the motor saver, down to right there on the motor saver. So what we do with this is we get 120 off your neutral and hot here, and we also have a 24 volt AC tap right here. Notice it's purple. If you look at our schematic, the wire for 24 AC on our schematic is also purple. So we try to make it as easy as we can to help troubleshoot these and follow wiring and stuff as much as we can. So if everything in the panels is gone, you don't have any power, this will be the first thing that you would look at is these fuses on here. Make sure you got 480 coming into it. Check these fuses. They do have finger tabs on them where you can just pull them out. I'd still turn the power off and just pull them out, check them with the meter one at a time. Check those fuses, see. You should get 480 across the top here, and then that would give you 120 across the bottom here. So you can measure that too.
So that one transformer does both 120 and 24 volt?
It does. It's got a tap right here for 24 volt AC.
Cool.
Now in this case, you notice a lot of our systems, especially if they're a surface water system, they may have a clear water screen out in a sump or out in the canal somewhere. We use a little 1-inch Rainbird solenoid valve for that to turn it on only when the main pump's running. So we don't have water going out to the spray nozzles on that screen all the time, only when the main pump is running. And it's a 24 volt AC coil. So that's probably the only thing in this system, that's the only thing that this is used for. This will jump down to the top of this very last breaker, and then from that breaker it's going to jump down to the purple wire that's here, and then this is going to wire out to that solenoid valve on the system. So again, as soon as the main drive starts, it actually runs from here up to the PLC and then down to here. And then when the PLC turns the main pump on, the relay output of the PLC closes and energizes that 24 volt AC coil on there.
Does it run off one of the slims up there?
No, I think this one actually does have a purple wire right there in the
Oh, straight
PLC,
out?
and
Okay.
so it comes straight off of that. Here's our breakers. Most of our systems will have a set of breakers in them, maybe 1, 4, or 5. Again, on the control transformer, we've got our 120 hot right here. It jumps down and goes straight into the top of this one. You'll notice there's 2 wires here. We just simply jump across over this one, to this one, and to this one. And that way our control transformer 120 volt is at the top of all these breakers, and then each one of these breakers will go out to a different circuit. It's labeled right here, CB1, 2, 3, and 4. You can look on the schematic, you can see that breaker. So if one's tripping, you can look on the schematic, see where that circuit goes, and narrow it down to maybe just a few items of what might be causing that circuit breaker to trip. Our 120 neutral from the transformer just comes to this distribution block. That's all it is. That just means that we can plug in a lot of different 120 volt neutrals to wherever they need to go. We also have one for 24 volt DC and the negative. It's kind of hard to see, but all of our 24 volt DC is a black with a red stripe. So if it's black without a red stripe, it's probably 120 volt hot. If it's black with a red stripe, it's the negative minus of the 24 volt DC power supply. And here we have our 24 volt DC power supply. This just comes down and jumpers into here, this one jumpers into here, and then we can take as many off as we need to go to the different 24 volt DC items, transducer switches, PLC, HMI, touchscreen, whatever's 24 volt DC is plugged into here. One thing to keep in mind that I see quite often is if this power supply goes out, you're not going to get a touch screen, a PLC, everything's going to appear like it's dead. You open this door, this little green LED should be on, but it's off, and at least once or twice a year I get somebody say, send me a new power supply. You know, it's dead. I measure 120 up here, but I'm not getting 24 volt DC down here. So of course you'd think it's the power supply right away. First, before you do anything else, pull this red wire out of here and test it again. A lot of cases, you're going to pull that red wire out of there. You're going to see that that green LED come back on, and the power supply is going to come back to life. The reason is that these power supplies are short circuit protected. So if you short this output out, it's just going to die, and you're going to measure 0 volts. But it's protecting itself. It's got short circuit protection in it. You could have anything else out in this 24 volt DC supply chain, you know, the transducer or something shorting out, and it would cause everything to go out because it shorts out this power supply. So if that ever does occur, you come across this, just pull that red wire out, measure it again, and make sure it's the power supply. We don't replace very many power supplies at all. Like I say, they're short circuit protected, and they just don't go bad very often at all. So if you do pull this wire out and the LED comes back on, then you've got to start tracing where it goes to. And that's another place where that field terminal strip would come in handy. You can just pull one out at a time until you identify what it is that's shorting it out. Here's a picture of a PLC. This is probably in 95% of our panels. We use this same IDEC PLC. We might only use just this gray brick here, depending on if it has enough inputs or outputs. On this one, what we've done is we've added another DC input module because we needed more inputs. If you notice on our schematics or look at our panels, you'll notice that we use blue wires for inputs to the PLC. That's a 24 volt DC input to a PLC. You're going to have one of these wires coming from the hand side of the HOA, another one from the auto side, one coming from the high pressure switch, whatever it happens to be on there. If it's an input to the PLC, it's probably a blue wire. Here's those purple ones again. Like I say, it comes from the breaker up to here and then from here back out to there. So the PLC controls that solenoid valve that goes out to clear water screen. Some of our fault lights, we might use yellow or an orange, or coils to contactors if they're 120. We use a dark brown. We have a black coming into here, which is probably like a common supply for several of these, and then we'll have a dark brown going into the coils on a contactor or something. Another thing I wanted to point out on this, and we'll probably get into it a little bit more in the advanced troubleshooting, is notice that on this PLC we have, there's a row of LEDs right here, here, and here. Some of these are power, error, and that, but there will be a number on the side of here for this row here of inputs, and then this row here is outputs. And then of course we have the additional inputs over here. We've got a row of LEDs over here. That's an input. The reason why that might be so handy is, let's say you walk up to the panel and turn it into hand and nothing happens. Well, a lot of times those switches get dirty or dusty or something. If you just look on the schematic, find that switch, you'll see right exactly what number it goes into on the PLC. Look over here, find that number. If you switch that switch from off to hand, you'll see that little LED go on, off, on, off. If you're not seeing any little LED go on, off, then the first thing I'd look at is the switch. Check the wiring there. It could be a major problem in the PLC or the programming or a fault or a high pressure shutdown, or for some reason it's not starting in auto, but in hand it should start. So. There's many other things, we'll touch on them too a little bit, on how these can become helpful, just looking at these little LEDs on the input of the PLC.
Terry, how long have you used that PLC?
Oh, we started with the IDEC in 90. When I started in 99, we were using the little IDEC brick, and then they've just kind of upgraded over the years. So we've been using IDEC for a long time. This particular
That's your current standard platform right
It
there.
is right there, yeah.
That, like, how long have you used that one, and how long do you, it's hard to gauge, I know, on PLCs, but I guess, how long do you think in the future you'll be able to continue to use that?
This particular style, I know we've been using for at least six or 7 years.
Okay.
And I think we'll just continue to use them. I don't see any reason why we would, not use them. We are adding newer PLCs, and of course we're getting, specs where it has to be an Allen Bradley or another type. But
Mhm.
as far as our standard, what we're going to use for our standard systems, this will probably continue to be the one for quite a few years.
Till IDEC says, we're gonna change them, fellas.
Yeah.
Yeah.
We did, however, for a while, switch from IDEC to Moeller. And then Moeller did that to us, and we went back. So I think probably 2 or 3 years we used Moeller. Well, we kind of used both, IDEC and Moeller, but we did use Moeller for a while. Then, of course, we got the keypad in here. This is where you would see a fault. If the touch screen says VFD fault, you have to open the door. This is where you look. It'll say fault. Then there's the jockey pump, the pony pump, VFD. A lot of our systems will use a VFD on the jockey pump also. Note that the keypads look identical. Even the parameters in this, this is an ACS 350 and that's an ACS 550. They're different model of drive, but the keypads will interchange. The parameters are the same, so once you know one, you know the other one. Then we come down, this is a Amiod control there's a protector on here, and then you got the contactor. This is a forward reverse contactor. You have to pay attention to the time to see what time lunch is.
This lunch.
Ooh, and not run over.
But we're very interested, Terry. Keep going.
Yeah, that's good stuff.
Yeah, this is a forward reverse contactor for the Amiod. We'll look at the Amiod filter in a little more detail, but when it does a flush cycle, it travels forward and then in reverse, and you'll see what I mean when we look at that. And so that's why we have 2 of these interlocked, so we can make the motor go forward one time and reverse the next time. So you'll notice that all of our items in here have some kind of a breaker or protector on it. The pony drive right here, the Amiod filter, the main VFD. You'll also notice that they're always labeled MPCV1. This goes to the main pump. This actually powers the drive. So if you notice in the wiring, we come down to the top of this protector, breaker, through a contactor, and then over to the power input side of the drive. The main reason for this contactor is to protect the drive in case of over voltage or under voltage. The motor saver, or this voltage monitor right here, sends a signal to the PLC saying that the voltage is okay, everything is fine. The PLC will then output on its output, energize the coil on this, and pull this contactor in, and that will power up the drive. So if the voltage monitor senses imbalance, phase imbalance, or loss of phase, or low voltage, the PLC is going to disengage this contactor, and it's going to pull the power from the drive. A lot of times it helps protect it. If you get real fast power surges or transients, it may not be quick enough to protect the drive, but it'll prevent it from running on too low voltage for too long. Let's see.
So you're basically sending a VFD enable signal from the PLC to the VFD when you want to start the motor.
Yes.
Okay.
Yeah. Our handoff
And then
auto
a speed
switch.
reference.
Yep. Our handoff auto switch will go to the PLC first,
Mm-hmm.
and then we'll output from the PLC to the drive.
Basically, a second safety.
Yeah,
The drive does its own checks, but who's gonna respond faster, the drive or that unit? Probably the drive,
most of the time the drive does, yeah.
Yeah.
Mhm.
so it's just a double safety is what it is.
Yeah. However, the drive will stay running on single phase power coming
To a
in
certain amperage, yes.
to a certain amperage. If it's only, going along at 50 hertz and you lose a phase, the drive may continue to run, but this is gonna, the motor's, voltage monitor is gonna shut it down right away. Cause it senses the loss of phase. and
That's
shut it
true,
down.
except for the drive, I think they carry, if one leg, if the wrong leg goes out on the drive, it's just gonna die.
That's on good issues on ABB.
On ABBs too.
Doesn't matter.
ABBs, it does happen too.
Does happen?
Yeah, cause they tap off the, just one of the
Yeah.
two legs to get
It's,
their
it's
step down.
U1 on the very left-hand side, that first input.
Yeah.
I think if you lose that, then the drive goes.
As a matter of fact, I have a D-rated drive, single phase, 240 volt, 100, we had about 100 horsepower drive in there.
It's
And,
around 50 horse motor.
Yeah, and and what happens is every time they have a brownout, the drive would fault. And they'd have to go in and reset the drive. So what I did was I eliminated that. So basically of course, when you got to lose a leg, lose power. Shuts off. And at this point, if you lose power, power comes back on, the drive says everything's okay, you want to turn on and go, but we had to take that, you had to shut that off, so that way you have to come in and reset it every time. So, and if it sees a fault in the power, it still will stay off. I mean, it's in the drive, the safety's in the drive.
So what'd you do, turn on automatic reset on that
No, I
function?
think it's, it was to, I forgot what it was, I had it written down in my notes. It was a job over in, Star Valley, I think, on one of those little double L lanes, I think. Stupid power out there, nothing. But, I forgot what did I do? I think I went into both, I researched it and I actually shut off, allowed it to actually turn on and off that fault. I just turned it off. I forgot which one I did. I registered it was, but that's what solved the problem.
You don't have any external phase monitor on it?
Well, what I did was, because it's a Flowtronics Oasis controller. Okay, so when the phase monitor would phase, when you go out, it would shut everything off. Okay, so to protect the phase, everything from getting surged on it,
Yeah.
I put in a UPS battery backup. Kept it live all the time, so now the power's live all the time, even if we drop out for at least 2 hours
Yeah.
because of the battery backup. And now and what we wanted to do was trace the fault. Well, every time it faulted, it would, no matter what we did with keep trying to follow that fault on that PLC, it would fault the drive. So to fix it, we had to shut off that fault. So with it,
Okay.
so in the drive, so now we can monitor any true faults because we're only single phase because of that drive. So losing a leg, I don't mean to go off on a tangent here on losing a leg on the
Cut into our
drive.
lunch.
It happens quite a bit. I mean, you see it every once in a while, you lose one of the phases or something. Another thing that this will do too is we have an auxiliary contact down here, and that's simply just an input to the PLC that says that this contactor is energized. So if this trips and this opens, then we know that this is faulted, that it's tripped. So let's see. Actually, that's just going to tell us that's just going to signal to the PLC that this is pulled in or not. Okay, let's see. Now we'll look at some of these overloads and, why they might be tripping and some of the different overloads. Here's 3 overloads. We still have quite a few of these out there and we still use them once in a while. This is just simply an overload for a contactor. There's a little indicator over here that says it's tripped. All you have to do is push the blue button. A lot of times if you push the blue button and it clicks, that means it's been tripped. So if you have an overload that keeps tripping, double check your amp rating right here. You can dial that. That's the setting for that overload when it's gonna trip. Might be one thing that you'll check. Another time when that clamp on amp meter might come in handy, check these 3 leads going out, see if, these will trip if a couple of them's normal and one of them's way over. Then we have another one, like the one we were just looking at. This one, if it's in the 12 o'clock position, it's on, and if it's in the 9 o'clock position, then it's off. But if it's halfway in between, about 10:30, that means that it's tripped. So if something's dead, you open the panel door and you see that sitting at about the 10 o'clock position, that means that overload's tripped. So then just start tracing, the output there to try to find out why it may have tripped. In this case, it's on the input of a drive. It could be that one of the input diodes of the drive's bad. Most cases, I would just turn the power off, reset it, close the door, turn the power back on, and see if it trips again. Well, let's go back to this one. This is on some of our bigger systems. This is a main disconnect overload with an overload, but it's also got an instantaneous trip. So keep that in mind if you're looking at if it's tripping and you want to double check and make sure it's set at the correct amp rating. One of these is going to be the normal amp rating like you would see on any other overload. Look at the rating in our schematics or on the VFD to check that one. The other one, if you look at it closer, it's going to be way over. It's going to be like 200% of normal. That's an instantaneous trip, which means it will trip really fast if you get a high spike. The voltage goes that high that quickly, it'll trip. A lot quicker than this one will. So there's just some of the different kinds of overloads. Again, amp check the motor. With a clamp on amp meter, on the motor leads or even on the input to the drive or whatever it's going to, you can check. Also, motor meg, you may have to meg the motor. Always remember to remove the leads from the drive before you do a motor megger test. Those will put out either, depending on the setting, 500 volts or 1,000 volt. And when you do a motor megger test on a motor, it could damage the input to a drive if you don't disconnect it from the drive. So always make sure that you disconnect from the leads from the drive. You check it from each input lead of the drive to ground to do a motor meg test. And what that's doing is it's testing the insulation of that motor to see if there's any breakdown in it, any leakage to ground. So you apply a high voltage to the motor windings. If they are breaking down, it's going to leak through there and go to ground, and the motor maker will pick it up. Also, remove motor leads and measure with ohms. Didn't finish the motor maker. These are just some examples of what you might see with the motor maker. When you do make a motor, if it's submersible down in a well, you do have to take into account for those long motor leads, because that's going to affect the measurement. Best thing to do is to find the wire size, the length of the wire, do the calculations, but sometimes that's not possible or it's difficult to do. But these are just some of the general guidelines. A new motor is 200 meg ohms. A good used one would be 10 plus. Anything under 8, it doesn't necessarily mean it's bad, but maybe we just need to look at it farther. Again, with long motor leads, this is just an example. It's really going to depend on how long those motor leads are. For every foot, you're adding more ohms to that reading.
As long as it's wet, you don't want to try to meg it. You don't want it to dry out or blow it out with.
That's true. It'll show bad if it's just got much moisture in it and stuff too.
See that a lot in my area.
See?
Oh, your leads can get saturated too, submersible leads cause an issue.
Mm-hmm. Or a little nick in the cable when you're putting it down or something. Or you can remove the motor leads and measure the ohms, compare with the motor manufacturer. A lot of times you have no idea what it is, or you don't have the manual, and they range in such a big range from motor manufacturers to the different types of motors. A bigger 6-inch submersible might be as high as, 12 ohms. I think a half horsepower submersible is like .007 or something, or no, it's the other way around. It's, they can be as low as .07, or a half horse submersible is like 38 ohms. So really what you're looking for when you're doing this is you're looking for some kind of an imbalance. Measure from lead to lead, T1, T3. If you're getting like, a half ohm between these two and a half between these two, and then you measure the other one and it's open or way over or a short, you're just at this point you're looking for some kind of imbalance rather than trying to match it up to exact motor manufacturers. If there's not any big imbalance, everything seems fine. There's a good chance that the motor's okay. You also want to check each motor lead to ground. That should be open. Motor saver. We'll go and look at these in a little more detail tomorrow, but basically they just monitor the phase coming in, the fault on over voltage, under voltage, phase imbalance. We do have, right here it says load energized, and then there's a little green LED right here. That's one thing helpful to keep in mind, make sure that green LED is on. What that means, load energized, all they're saying it means is that they're energizing this coil right here. We got 24 volt DC right here, and we got a blue wire going to an input of our PLC. Once this says load energized and voltage is okay, it closes that, and so the PLC gets a signal saying that the voltage monitor says everything's fine. So make sure that this LED is on. If it's not, there could be a fault. Also, the red fault light will be on probably 9 times out of 10. If it sees a power failure or you turn the power off to open the door, it records that. This red light stays on until you reset it. So just because that light's on doesn't mean that there's a fault. You can press the read button and it'll go through. Actually, it might be the fault button. It says it underneath here. I'll have to look at that and I'll be sure about that again tomorrow, but I think pretty sure it's the fault button. If you press that and keep pressing it, it'll go through a list of the last 12 faults. So it stores faults in there. If you hold that fault button down for about 3 or 4 seconds, it'll clear all the faults. I usually read them and then push the button and clear all the faults just because I like the red fault light to go out, and make sure that that green load energized is on, and that's a voltage monitor. Again, I'll point out the field terminal strip. Here's an example of a sticker of a label that you'll see right below it. It's down in the bottom of the panel right there. It corresponds to every one of these that's numbered. Like I say, you can test the pressure transducer right here, check a flow meter. The remote start input that we were talking about, if it has that local remote switch, that would be an input. Temperature switches, flow switches, they're all right here. So you can simply just start pulling these wires out if you're testing, like I said before, the power supply, pulling those out, or you may have to pull one out and put a meter on it and test it. So keep in mind the field terminal strip, what it is, and it can be useful too. Here's an example of our schematics. You'll notice how they're all color coordinated, color coded. We always use brown, orange, yellow for 480 volt systems. We'll use red, black, blue for our 240 volt systems. So you'll notice that here's a picture of the PLC I was talking about before. If you switch the switch to hand, you see this blue wire comes down, goes into this input number 1. So this little LED right by number 1, there'd be a number 1 up here, and that LED would come on and off when you're switching it. If you're playing with the pump station down there later on today or something, you might look at that, you turn those switches and see